Today, we're going to talk about one of the conic sections, the parabola. So our goal of this video is first to identify the key components to a parabola. Second, know how to graph a parabola in standard form. Alright, next. A parabola is a set of all points x and y that are equidistant from a fixed line called the directrix and a fixed point called the focus. So here's focus. This F stands for focus. This blue line is a directrix. This yellow shape is called parabola. And as you can see, this segment and this one are equidistant, which means the lengths of these segments are the same. Same here, same here. Yes. Hello guys, here's 4 main equations for parabola. So the first one, basically these 4 equations are used for parabola. These are having basically the same concept, but for their different purposes, they're used in different ways. So first one, this equation is standard form of parabola. The second one is the vertex form of parabola. And third one is for interception. Fourth one is a focus. Fourth one is for focus of parabola. Bye bye. Okay guys, here is a parabola with vertical axis. So the formula of parabola with vertical axis is x squared equals 4py, as you can see right here. And there are 3 properties: vertex, focus, directrix. And always in parabola, the vertex is 0,0, focus is 0,p. The p refers to this one, and directrix is y equals -p. And you can see these 2 different shape of graph. Alright, this graph is showing x squared equals 4py with when p is greater than 0. So the parabola opens upward if p is greater than 0. Meanwhile, in this graph, you can see x squared. You can see the graph of parabola x squared equals 4py with p smaller than 0. So the parabola opens downward if p is smaller than 0. So opens downward. But there is a correlation between these 2 graphs. These 2 graphs are symmetric, because even though the x value is a negative, it always turns out to be positive since there is a square. So this is the reason why these graphs are symmetric. Guys, this time it's about parabola with horizontal axis. So the basic equation of it is y squared equals 4px. So here are 3 properties as well: vertex, focus, directrix. So vertex, as I mentioned before, parabola has always vertex 0,0. Focus, this time focus is p, 0. Last time it was, when parabola with vertical axis, it was 0,p, but this time it's focus is p, 0. Directrix is x equals -p. The last time in the vertical axis it was y equals -p. And you can see 2 graphs right here. So guys, as you can see, the parabola opens to the right if p is greater than 0. And in this graph, the parabola opens to the left if p is smaller than 0. And yeah, same, the F stands for focus, and this blue line is a directrix. And these graphs are symmetric. These graphs are symmetric because even though there is a negative value in y, as long as you're square, it's always positive. It turns out to be positive. Number 1. Sketch the graph of the parabola.
Okay, the equation is x squared over 21 equals to y over 3. So the first step, you try to make it into the focus form, the standard form. So we move 3 over to the left side, which is 3x squared over 21 equals to y over 1. And the second step, we simplify it, and it turns out to be x over 7 equals y. And we know from the equation x squared over 4p equals to y. So we know that 4p equals to 7. And this is the third step, by the way. And so after calculation, we know that p equals to 7 over 4. And now we can sketch the graph. And we know that we first make a coordinate system like this. And we know that the vertex of the parabola is at the origin. And the focus is 7 over 4, and which is a 7 over 4 unit up, and we scale it and make it 1 and 2, and the focus is about here, which is 7 over 4, 0. So we can simply make a sketch like this. And here's a simple sketch of the graph.
Number 3. Determine the vertex of the parabola.
Okay, so the question is x squared minus 6x equals 8y minus 73. Okay, so the first step, as we know, it's obvious that this question is a shifted parabola. So the first step, we first add 9 on the left side to complete the square later on. And if we add 9 on the left side, we must add 9 on the right side as well. So the second step, we complete the square. And it's x minus 3 squared. And the right side turns out to be 8y minus 64. And the third step, we take the 8 out of this thing, and it turns out to be 8y minus 8. Okay, so here's the shifting part, the minus 3 and the minus 8. If it's minus 3, then we know that it's moving 3 units to the left side, and it's y minus 8, so we know it's moving 8 unit up. So the vertex is v3, 8.
Okay, so now we're going to talk about the parabola in real basketball application. And as we can see, the ball starts from here and then enters the maximum point and then lands into the hoop. So we can see that the shape of the basketball path is a parabola. And now we're going to copy the graph onto a white paper. So it will be like this. The ball will start from here and reach the maximum point and land it somewhere here. And this will become the path of the parabola. And now we need to find the equation of the parabola. And we know that this point is the origin, which is 0, 0. And at the maximum point, according to the grid, we calculate that it's 9.6, 7. And now we're using these 2 points to find the equation of the parabola. And we know that the standard equation is y equals x squared over 4p. And since the graph is shifted to the right and to the up, so we need to change the equation a little bit. We change it to y equals to negative x minus 9.6 squared over 4p, and then plus 7. Then minus 9.6 means it's shifted to the right 9.6, and then the 7 means it's shifted upward 7. And now we need to plug in the origin point into the shifted equation. So we'll get 0 equals to negative 0 minus 9.6 squared over 4p plus 7. And the negative sign means that it's opening downward, so we need to add a negative sign here. And then now we can solve for p, for finding the p value. We'll get negative 7 equals to negative 9.6 squared over 4p. Since both sides has negative sign, we can just cancel out, so we'll get 7 equals 4p and negative 9.6 squared. And then after we're solving, we'll get p equals to 3.29. And then now we need to plug the p back to the equation. We will get y equals to negative x minus 9.6 squared over 13.16. That equals to 4 times p, and then plus 7. And that will be the equation of the parabola for this one. Okay, so now we're doing another example. And now this is another basketball path, which is also a parabola. And we can see start from here, reach the maximum point, and goes in the hoop. So now we need to do the same thing, find the equation of the parabola. So, and now this is an example of the parabola. As you can see, it starts from 0, the origin, and then pass to the maximum point, which is 5.5, 5.5. And then, so the 5.5, 5.5 is the vertex, and origin is the x-intercept. We still use these 2 points to find the equation of the parabola. So now this is standard equation, and then we do the shifting, we get the shifted equation like this. And after the shifted equation, we plug in the origin number, which is 0, 0, and we got this equation. And after all the calculation, we got p equals 1.375. And now we plug 1.375 back to the equation to get the real parabola equation, and we get y equals x minus 5.5 squared over 5.5 plus 5.5. And that will be the equation of parabola for this basketball path.
Now Ethan is shooting the basketball, assuming the ball starts from origin. The coordinate of the highest point is 6, 5. A. Write the equation of the parabola and the directrix. B. If the basketball hoop is 8 meters in front of Ethan and it is 3 meters tall, will Ethan shoot the basketball into the hoop? If not, what will be the height of the basketball?
So now this is another application problem of the parabola question, and this is the questions. So it's basically asking about write the equation of parabola and the directrix, and the second question is asking about will Ethan shoot the basketball into the hoop or not. And for solving this equation, we basically do the same thing as the previous two examples. First, we find the equation of the parabola, which is y equals x squared over 4p, and we know that the equation will be shifted in this kind of question, so we're just going to change the shifted equation into y equals to, and since the maximum point is 6, 5, we know that I shifted to the right 6 and shifted to up 5. So we'll get that y equals negative x minus 6 squared over 4p plus 5. The negative sign is for the same reason, because opening downward, so it will be always negative. And then now we need to solve for p. So we plug in the origin coordinate, which is 0, 0. So we get 0 equals to negative 6 squared over 4p plus 5. And after all the calculation, we could get that p equals to 1.8. And then now we just need to plug it back to the equation. We'll get y equals to negative x minus 6 squared over 7.2 plus 5. And now we need to find the equation of directrix also. So since we know that the distance from the vertex to the focus is the same distance from vertex to directrix, and we know that the distance from vertex to the focus is 1.8, so basically just 5 plus 1.8 equals to 6.8, and so we can know that the equation of directrix is y equals to 6.8, and that would be an equation of the directrix. And for b, we need to plug in the number and see if it was equal, so we can tell that it was shooting a basket or not. So now we have the equation of the parabola. So we plug the equation. We'll plug the number, which is 8 and 3, into the equation. We'll get negative 2 squared over 7.5 plus 5 equals to 3. And after all calculation, we can get that negative 2 equals to negative 0.555555, which is not equal. So we can tell that the basketball won't go into the basketball hoop. And now we need to find the height of the basketball at that point. And we know that the horizontal distance will always be the same, so we still use the 8. So basically plug 8 into the equation and try to find the y, which is the height of the basketball at that point. So we plug in, so we got negative 2 squared over 7.5 plus 5 equals to y. We get y equals to 4.44. So we know the height of the basketball at that point is 4.44 meters tall.